Hello, my dear students. Last class I explained about the thin cylinders and also how to find the circumferential stresses, right? Circumferential stress can be calculated by using the formula PD divided by 2T. Today we will discuss how to find longitudinal stress. Okay, longitudinal stress means here the stresses are acting along the length of the cylinder. Okay, let us consider a same cylindrical shell subjected to same internal pressure as shown in the figure. We know that there is a result of internal pressure. The cylinder also has a tendency to split into two pieces as shown in the figure. In the previous problem, it was divided into two tubs. Now it is divided into two cylinders. Okay. Now let P is the intensity of internal pressure and L is the length of the shell and D is the diameter of the shell and T is thickness of the shell. Okay, here the stresses are developed along the length of the cylinder. Okay, now total pressure along its length, say y axis of the shell, that we have to calculate. What is that? P is equal to intensity of internal pressure into area. Okay, intensity of internal pressure, that is P. Area is area of the cylinder. Now it is cut into two cylinders, so area is given by pi divided by 4 into d square. This is the area of the cylinder. So total pressure is equal to intensity into area. Intensity is equal to P. So total pressure is equal to P into pi by 4 into d square. Now we'll calculate what is the longitudinal stress in the shell. So longitudinal stress is represented by sigma L is equal to same formula, total pressure divided by resisting section or resisting pressure. That is, total pressure is this one, P into pi by 4 d square divided by resisting section. Here resisting section is pi into d into T. Okay, this is the thickness and this is the diameter. Okay, so pi into d into t, that is, when you simplify this you get pd divided by 4t. So this is the circumference longitudinal stress. Okay, this is also a tensile stress across the y section. It may be noted that longitudinal stress is half of the circumferential stress. Always you have to remember that longitudinal stress is equal to half of the circumferential stress or Hooke stress. Suppose if there is a efficiency of the is efficiency is nu, then the stress is given by sigma L is equal to PD divided by 4 into T into nu. This efficiency, that is nothing but the loss. If there is some losses while riveting the joints, so you have to consider that it may be 70% or 80% or 90%, whatever. So just consider that if there is a efficiency, you have to use this formula. Otherwise, longitudinal stress is equal to PD divided by 4T. So this is the way to find the longitudinal stress. So yesterday class I have told about circumferential stress. So circumferential stress sigma C is given by PD divided by 2T and longitudinal stress, that is given by sigma L is equal to PD divided by 4T. We'll take one example how to find the circumferential and longitudinal stresses induced in the plates or a boiler. Okay, a steam boiler is of 800 mm diameter is made up of 10 mm thick plates. If the boiler is subjected to an internal pressure of 2.5 MPa, find the circumferential and longitudinal stresses induced in the boiler plates. Very simple example, direct substitution. If you know the formula, directly you can calculate what is circumferential and longitudinal stresses. What is given here, diameter is given, that is 800 mm, and thickness of the plate, that is equal to 10 mm, and pressure, internal pressure is given, P is equal to 2.5 MPa or 2.5 into 10 raised to 6 Newton per meter square or 2.5 Newton per millimeter square. So let us calculate for circumferential stress. Circumferential stress induced in the boiler plates is equal to sigma C C is equal to PD divided by 2T. So P is equal to, what is that, 2.5 into D is diameter 800 mm divided by 2 into T is 10. Substitute, you get 100 Newton per mm square. Next we'll find longitudinal stress induced in the boiler plates, that is equal to sigma L is equal to PT divided by 4T. So P is 2.5, D is 800 divided by 4 into thickness is 10. So you get 50 Newton per mm square or 50 MPa. As I told, first only longitudinal stress is equal to half of the circumferential stress. So you can see here, this is 100 and this is 50. Okay, let us, I hope all of you understood. Very simple example. Let us take one more example. A cylindrical shell of 1.3 meter diameter is made up of 18 mm thick plates. Find the circumferential and longitudinal stress in the plates. If the boiler is subjected to an internal pressure of 2.4 MPa, take efficiency of the joints as 70%. Here efficiency of the joints is given as 70%. So what formula you have to use? You have to use sigma C, circumferential stress, is equal to PT divided by 2 into T into nu. Similarly, for longitudinal stress, P is equal to sigma L is equal to PD divided by 4T into nu. Okay, here it is diameter is 1.3 into 10 raised to 3 mm. Thickness of the plate is 18 mm. Internal pressure is equal to 2.4 Newton per mm square and efficiency is equal to 70%. So that is nothing but 0.7. So calculate circumferential stress, that is equal to PT divided by 2T into nu. So substitute all the values. P is 2.4 and D is 1.3 into 10 raised to 3 divided by 2 into 18 into 70% is 0.7, that is equal to 124 Newton per mm square. So longitudinal stress is equal to PD divided by 4T nu. So that is 2.4 into 1.3 into 10 raised to 3 divided by 4 into thickness is 18 mm and efficiency is 0.7%. 0.7. So you get 62 Newton per mm square or 62 MPa. You can see here, this is half of the circumferential stress. Longitudinal stress is half of the circumferential stress. This is the way to calculate directly the longitudinal stresses and circumferential stresses. Sometimes what happens, the cylindrical shells, when it is subjected to pressure, there will be change in the diameter, length and volume. Let us see that how it changes. Okay, now next is change in dimensions of a thin cylindrical shell due to an internal pressure. So we have already discussed this in the chapter elastic constant, that lateral strain is always accompanied by a linear strain. What is lateral strain and what is linear strain? Linear strain is, it is the strain developed along the length of the axis, means force is acting along the length of the axis. Lateral is, it is acting perpendicular to the force or line of the axis. So here, same thing, this already I have taught in the unit 1, lateral strain and linear strain. So lateral strain divided by linear strain, that is nothing but Poisson's ratio. So it is obvious that in a thin cylindrical shell subjected to an internal pressure, its walls will also be subjected to lateral strain, because when the cylinder is subjected to internal pressure, tensile stresses are developed. Once the stresses are developed, obviously strains will be developed, also subjected to strains. So if there is a linear strain, there should be always lateral strain also. The effect of the lateral strains is to cause some changes in the dimensions, that is the length and diameter of the shell. So there may be, because of these changes in the lateral strain, there may be change in the length and diameter of the shell. Now let us consider a thin cylindrical shell subjected subjected to an internal pressure. Okay, length of the shell, and d is the diameter of the shell, and t is the thickness of the shell, and p is the intensity of internal pressure. Let us assume one cylinder and it is subjected to internal pressure. Okay, so these are the dimensions. Now what happens? We know circumferential stress is equal to sigma c is equal to pd divided by 2t, and longitudinal stress is equal to pd divided by 4t. So this delta D is change in the diameter of the shell, and delta L is change in the length of the shell, and 1 by m or mu is equal to Poisson's ratio. Now this is related to stress. So what is strain? Direct strain due to circumferential stress, that is equal to, strain is represented by this symbol, and this is circumferential, so therefore I have written C. Okay, circumferential strain is equal to sigma c divided by E, by Young's modulus is equal to stress divided by strain. So strain is equal to stress divided by Young's modulus. So that's why it is written here. This is the strain. Strain is equal to stress divided by Young's modulus. But this stress is circumferential stress here. That's why it is written sigma c. Similarly, direct strain due to longitudinal stress, that is sigma L. This is strain L is equal to now sigma L, because longitudinal strain divided by E. So this is the strain, this is stress. Sigma C is equal to PD by 2T stress, and this strain is equal to sigma C divided by E. Similarly, longitudinal stress is equal to PD divided by 4T, and longitudinal strain is equal to sigma L divided by E. Now we have to calculate what is direct circumferential strain. That is nothing but direct strain minus lateral strain due to the direct strain. So total, now we have to calculate circumferential strain and longitudinal strain. That is nothing but direct strain minus lateral strain. Okay, what is direct strain? Direct strain is, in the case of circumferential stress, that is given by sigma c divided by E here. Direct strain is suppose if it is direct strain, circumferential strain is always related to diameter. It is changes along the circumference of this cylinder, so that is change in the diameter. So this is circumferential strain is equal to change in the diameter divided by original diameter. And also, how this direct strain is sigma c divided by E, that is circumferential strain, minus lateral strain due to direct strain. Lateral means you have to multiply it by Poisson's ratio into this sigma L divided by E now. Okay, so that is equal to, when you simplify this, you get sigma c divided by E minus sigma c into 2me. Why 2me? Sigma L is equal to, I have told, circumferential divided by 2. Longitudinal strain is always equal to half of the circumferential strain. So once if you substitute this and simplify, you get this formula. So this circumferential strain is given by Pg divided by 2Te into 1 minus 1 divided by 2m. Okay, then we'll calculate net longitudinal strain. That is also same formula. Now is longitudinal strain is equal to, that is change in the length divided by original length. How we can write in terms of direct strain? This is now related to longitudinal. So first sigma L divided by E minus lateral of circumferential strain, that is 1 by m into sigma c divided by E. Simplify this, sigma L divided by E. Now longitudinal, this is actually circumferential stress, that is 2 times of longitudinal stress. Okay, divided by ME. Simplify, you get longitudinal strain is equal to PD divided by 40 into 1 minus 2 divided by M. This formula you have to remember. Okay, now changes in the diameter and length may be found out from the following above equation. As usual, by multiplying the strain, the corresponding the linear dimension. So you can write in terms of delta D also, then this is the formula. If it is terms of delta L, this is the formula, or you can write this also. Okay, delta L is equal to PDL divided by 14 to 1 minus 2 divided by M. Thank you.